Today our topic is pairs of lines and angles. So our essential question is, how can I identify angle pairs formed by three intersecting lines? Key terms, parallel lines. First, our symbol for parallel lines are two straight lines that look like they're parallel. You can see an example of this here where it says that would be M is parallel to N, so line M is parallel to line N. And our definition for parallel lines are lines that are coplanar, so on the same plane, and do not intersect. They will never intersect, never cross. Skew lines are lines that are not coplanar and do not intersect. And then parallel planes are planes that do not intersect. So you've got some examples of these down here. One thing to note are these little triangles that are on the lines. Those triangles denote parallel lines. Okay, I know you don't have this on your paper. We'll get another example of this later on in the notes. But those little triangles that are on the line mean that the lines are parallel. So interpreting a diagram correctly means that if those triangles are there, we can claim the lines are parallel. Example 1. Think of each segment in the figure as part of a line. Which lines or planes in the figure appear to fit the description? So we are going off of appearance here. Lines parallel to CD containing point A. So parallel means they need to be on the same plane. So if we look line CD and point A, so we'd have to look at this plane right up here, this top plane. So parallel would be this line right here, line AB. Lines skew to CD containing point A, so they don't cross, but they're also not on the same plane. So if we look containing point A, we'd have this line. So AH would not be on the same plane, and it does not cross CD. Also, this line right here, AG, would also be skew. They don't intersect with CD, and it also does not lie on the same plane. Okay, next one is lines perpendicular to CD containing point A. So perpendicular would need to be on the same plane and crossing at that 90-degree angle. So if we look, here's that 90-degree angle. So line AD would be perpendicular. And then planes parallel to EFG and containing point A. So we find plane EFG, which is going to be this plane down here on the bottom. So parallel would be the plane on the top of the box because it contains point A. So we would say plane ABC. You'd also name it plane DCA, ACD, ADB, whatever you want to call it with the 3 points on that plane. Next piece, if you look at your resource sheet, we have two postulates. We have the parallel postulate and the perpendicular postulate. Parallel postulate states if there's a line and a point not on the line, then there's exactly one line through that point parallel to the given line. So if we're given line L and point P not on line L, then there is exactly one line that will be parallel to line L through that point. Same concept, but with perpendicular. For the perpendicular postulate, if you have a line, point not on the line, then there will be one line that goes through that line that is perpendicular through that point. Example 2, name a pair of parallel lines. Name a pair of parallel lines. So if we look at our diagram, we need to look for those little arrows, which are right here. So the lines with the arrows are parallel. We can't claim any other lines are parallel. So we would say line MK is parallel to line LS. Name a pair of perpendicular lines. So we look for that right angle, which right here we can see that right angle is resting on this line here and this line here. So be line NP is perpendicular to line QP. is PN, line PN, parallel to line KM? So if we look for PN, which is right here, and then KM, which is right here, are those parallel? No, because they intersect. And our definition of parallel lines is that they do not intersect. So since they intersect, they cannot be parallel lines. And then PR is PR perpendicular to NP. So if we find PR right here, and then NP right here, we could say no, because they do not intersect at a right angle. All right, next piece. Angles formed by transversals. So if you look at your resource sheet, first off, let's define what a transversal is, which I don't have on my screen, but you have a little box on your note sheet that has key terms, and it says the word transversal. So in that box, you're going to have a line that intersects two or more coplanar lines at different points. So a transversal is a line that intersects two or more coplanar lines at different points. So here we have a bunch of different examples of transversals. So we have two lines. So these lines are coplanar, being intersected by another line. So this line is called a transversal because it intersects two or more coplanar lines at different points. So that line intersects both of those. So that is called our transversal. And it forms these different angle pairs. So these two angles, 2 and 6, are called corresponding angles because they have corresponding positions. So if we look at the two lines, they're both on the top right-hand corner of where the transversal crosses. Also, these angles right here would be corresponding. These angles here would be corresponding, and these angles here would be corresponding. So there will always be 4 pairs of corresponding angles in a set. The next one is alternate interior angles. So if we look, we have our two lines being cut by a transversal. So where the transversal cuts, we have in between the two lines, which we call our interior, and outside the two lines, which would be called the exterior. So with two angles on the interior, we have this relationship of alternate interior because they're on alternate sides. And then also down here, we have consecutive interiors. So they would be on the interior, but on the same side of the transversal. And then the last piece would be alternate exterior. So instead of being on the interior of the two lines, they lie on the exterior and on opposite sides. We're going to be using these a lot, so make sure you grasp where these angle pairs are and know the difference. So let's put that into practice. Identify all pairs of angles of the given type. So if we look first, let's identify our two lines. Here's our two lines that are being cut by a transversal. So there's our transversal going through the two lines. We need our interior and our exteriors labeled. Okay, so now corresponding angles would be the angles that correspond to the same location on the line. So we'd have angle 1 and angle 5. They're at the same location on the two lines, just on the different line. So angle 1 and angle 5 would be corresponding. Angle 2 and 6, they're also both on the top right, so they correspond. Angles 3 and 7, they're on the bottom left. And then lastly, we have angles 4 and 8 in the bottom right. So those are your pairs of corresponding angles. Then if we look for alternate interior, so we're looking on the interior, alternate, so on alternate sides. So 2 and 7 would alternate, right here and right here. And then the opposites would be here and here, the alternates. So angle 4 and angle 5. alternate exterior, so now we're looking on the exterior. We're looking for those alternates. So we have the top, left, bottom, right. So that'd be angle 1 and angle 8. And then we also would have the bottom left, top right. So angle 3 and angle 6. And then the last piece would be consecutive interior. So we're going back to the interior. But we want the same side of the line. So here and here. So angles 2 and angles 5, and then angle 4 and angle 7. Last piece here. Classify the pair of numbered angles. So first off, identify your two lines. Identify your transversal that's cutting through. Label your interior and your exterior. So if we look, both the angles are not in the interior and both are not in the exterior, which means that they're going to be corresponding angles. They both correspond to the top left of the blue line. So they are corresponding angles. Example number 4. Again, identify those two lines. Identify your transversal. Label your interior and your exterior. Both the angles are in the exterior. We have top right, bottom left. So we would say they are the alternating exterior angles. And last example. Again, identify your two lines. Identify your transversal. Label your interior and your exterior. Both of these are on the interior and they're on opposite sides of the transversal, which means that they are alternate interior angles. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.